I am a developer, um, so a lot of this is focused in that way, but I'm also a security architect. So essentially, it's like trying to use all that development experience and marrying it with security. So you'll find lots of references to actual settings or configuration things, but we may not have time to go into some of those, so we can cover those later as well. So at any time, feel free to stop me. We would just encourage this as an open discussion. A little bit about me. So I'm a security architect for a company called Pros Incorporated. We are a software company, but we are a big data science company essentially. We develop pricing tools based on big data. So big data is part of what we do. I'm not on Twitter. This is what came out, I think last year, right? A couple of years ago. Definitely not on Facebook. So I get like emails from my friends saying, I have like 200 password reset emails. And I'm like, thank you. He's just validating my reason not to be on it. I'm on LinkedIn though. I mean, LinkedIn is equally, in the same category, but that's a professional compulsion. So what we'll cover is what is big data. How many of you are familiar with big data? How many of you are familiar with Hadoop, Cassandra? It's a good size, so we can skip some of those. The security concerns with big data, and then this talks about generic concerns as well, and then I will use Hadoop and Cassandra examples basically to talk about some of the specific things that I have problems with. We'll look at some of the existing controls, solutions, depending on which audience you talk. Some refer to it as controls or solutions for big data, the security solutions. Why those solutions are inadequate, why in some cases they don't apply, or in some cases it's just too hard, basically, or not feasible. And lastly, we'll cover what we should actually be doing. Any questions so far? So what is big data for some of you that didn't raise their hand? So I like that there's a definition. I think that the Cloud Security Alliance and some of the other organizations have tried to come up with, but anything that crosses 4 or 5 sentences is very hard to understand. So I still think of big data as volume, velocity, and variety. So 3 V's. Very easy to understand, very easy to picture it, and essentially say, okay, this definitely is a big data installation. It may not have some of the other characteristics like, for example, the distributed nature of it. For instance, SAP HANA, is that really big data or not? So it may not be distributed. It may be one monolithic server, right? So we don't know. So that's why there are certain traits or characteristics of big data. But in general, I just think about big data as volume, velocity, and variety. So Hadoop framework. So this is my own rendering of Hadoop based on what are very common components of Hadoop. Cassandra there, for people who are familiar with Cassandra, you can even replace some of the HDFS ones with just Cassandra, but it's very hard to configure it to completely replace it. But in general, you have a distributed file system, right? And you build computation capacity on it. So you have MapReduce, and then you have data flow language and essentially SQL access to it. So very modular structure. It's the most popular one. It's almost synonymous with big data. A few capabilities, you're already familiar, MapReduce, distributed storage. So again, this is something that you all might be aware of, but I just wanted to bring it out to put some context around the things that we'll be talking about. So you have data nodes, and essentially your MapReduce jobs run close to those data nodes. So you have task trackers and tasks that actually run close to your data nodes. So your data nodes have the actual data, and your computing is running close to that data. Name node has the metadata of the entire file structure, so it basically knows where the piece of data actually resides and can respond to queries. And you have clients interacting with these. So it's very short introduction to the HDFS one. So I wanted to introduce NoSQL. How many of you are familiar with NoSQL? It's probably the same crowd as Hadoop and Cassandra. So again, it's basically not only SQL. You have Cassandra and MongoDB as two examples of NoSQL stores. It's not your typical RDBMS. Cassandra, for example, requires a very different mindset to essentially manage, to essentially create what we call schema. It's not exactly a schema, but to manage that, to manage the column families and deal with it on a daily basis and understand some of the key things that Cassandra brings. So a lot of folks use it, apart from the big data needs, a lot of folks use it because it's highly available, partition tolerant. You can define strategies for your key spaces and separate them out per tenant or customer or however you want to. MongoDB, we do use MongoDB as well. It's not as high as Cassandra. So our favorite question, is big data secure? So I think as most of us, and especially security folks that work with big data or use big data, to me it's obvious. It is an afterthought, right? They probably concentrated on performance, availability, scalability, and those were much more important in terms of what big data was meant to do. So security was pretty much an afterthought, and even just ignored in up to its initial stages. But the focus is shifting now. With Hadoop is gaining a lot of popularity. You will find that I have some references to surveys that basically talk about the percentage of use Hadoop has, but I think in one of the surveys it was like 62% of the enterprises use Hadoop in some way or the other. So it's gaining. It's gaining in popularity. So security is not being ignored now, so you'll find lots of discussions around Hadoop security, big data security in general, some of the other issues around Cassandra, for example, and these open source projects are responding in kind. So there are three problem areas: the nature of big data itself, the deployment of big data, the enterprise adoption of big data. So, and we'll cover some of those. So the not so secure nature of big data basically boils down to issues with ownership, privacy, integrity. It's very hard to identify sensitive data in some cases because data is has variety, right? So it dynamically you can start adding new columns, new attributes to your column family. It's very hard to define that. Okay, like in a typical RDBMS, it's very hard to define a schema and say this is what I'll be accepting. This is what I'll be accepting, and this is my general schema. So again, that makes it harder to identify sensitive data. There's no password field. It could be called anything. It could come in many different forms. Then liability and litigation associated with who owns data once you transform, analyze, and present results. Who owns that result now? Because it could be combined from two different sources. It's prone to insider attacks, especially analytics. For companies that deal with big data analytics, it's a big problem. Essentially, you have raw data, and after running your computation on it, it could now start to become meaningful, where you can make inferences about customer behavior, you can make inferences about pricing, you can make lots of judgments, right? So those are prone to insider attacks because now you can actually look at some of these things. So there are provenance issues which basically just talk about how did this data originate, who originated it, who's the rightful owner for this particular data. So, and in general, traditional controls are ineffective. So, like you might know, right? Just think about traditional security controls. So traditional controls now that file system control needs authentication to basically first figure out that this is the right person, right, accessing that particular data. And big data installations, that HDFS could be used by Cassandra. let's say Cassandra has some data, and what it is doing is using HDFS as just one other store to store metadata, but Cassandra is the one with the actual data in it. So now you might have Cassandra nodes distributed across this. How do you secure those? Then you might have your tasks running on the same machines as the HDFS data nodes. How do you secure those? So what happens is traditional controls start to become ineffective. And in a lot of cases, you need what the industry calls forward-looking security, which means trying to predict what this model will become after analysis and after computation, right? So again, as the picture shows, the links could be tampered. If you have a big data installation around collecting device data or data from your sensors, you could essentially compromise that device itself. Again, raises provenance issues. If I'm using that as part of my analytics, is that data really reliable? Can I really trust that? If I'm measuring weather data, are those sensors really reliable? And in a lot of cases, these devices do not have that security built in because, again, it was not designed with those security things in mind. So deployment security issues. Again, this is not Hadoop specific. It could relate to other ones, but Hadoop is a good example, for instance. So we have a large attack surface, right? You have data nodes, you have name node, a secondary name node, you have job trackers, you have task trackers, you have tasks actually running. You also have other additional services that want to connect to these. So it's a large attack surface, and it could range from a 2-node cluster to a 1,000-node, or in some cases I've heard 4,000-node cluster. So very large attack surface, and that to security professionals in general, signifies trouble. Services could be impersonated. You could have rogue nodes. It's not too hard to become a service essentially if you have the right credentials or if you know something. So we'll see some examples of those. It's very difficult to determine data loss. So if you talk to compliance or audit, people, and I think Dave Hansen in his keynote referred to, right, compliance is not security. So they would say, oh, I want a data loss prevention tool, like DLP tool. How do you put that here? How do you really determine if data was lost or not lost? Let's say somebody just captured data from one node. The cluster would recompute itself. It is highly available and tolerant, right? So it would recompute itself and still give you back your data. It's very hard to determine data loss. And again, as we saw, it has non-traditional security needs. There's no choke point. There's no single choke point that you can say, okay, I will put a firewall here and stop everything. It's very hard to do. It's possible. It's very hard to do. And even if that is, you do it in some way or the other, you essentially run into security scalability concerns. Will my solution really scale? Will this security solution be able to meet the demands of big data itself? So as we are doing this, we should not forget that big data was, the main reason was for massive storage and massive computation. So anything that stops us from doing that is not a viable solution. So any questions here? So again, this is not, I'm not picking on Hadoop, but just using that as an example. So again, not designed with security in mind. So I'm not questioning again why we need multiple communication protocols, why we need multiple authentication mechanisms. It could be how performance might have been a reason, right, where which dictates which ones you actually end up using. But still, I mean, as we design systems and security professions, the first thing that comes to our mind is simplicity, right? Trying to, a complex system is not secure or cannot be secure because there is some part that somebody doesn't understand, and that's where you have opportunities for attacks. Multiple endpoints, you have APIs, you have nodes, the nodes, physical nodes themselves. In most cases, they are just commodity servers, or if you're leasing these servers, then they may not be hardened. You run into all issues associated with traditional security around a physical box. You have web apps and you have web app security issues, including OWASP top 10 type of issues in those. So the biggest problems tend to be around the area of no security. Default is no security. So if you have, if you ever brought up your Hadoop cluster, I think some of you might have done this on your own, right? I mean, you just bring up the entire Hadoop cluster. What do you see? There's no security. So just imagine, not all of us are admins. I mean, we have development background in some cases. We even understand scripting. We even understand the network protocol side of security. But still, we are not admins. So when you bring up a system with no security, it is a difficult task to go and configure this. So for example, job tracker, name node, task tracker, they're all accessible. They're all ports are accessible. User identity can be easily spoofed. I think I have an example for that somewhere later. Permissions can be circumvented, and simply because there's no authentication. So if there's no authentication, how will you authorize somebody, right? So if you're saying, okay, only super user can modify this particular file, but I can become the super user, right? So because you're not authenticating super users. So it does have permissions based on file permissions. So the HDFS model itself on file permissions to enforce authorization, but again, it's ineffective because authentication was not there by default. Again, rogue services, you can have a piece of code that comes up, Java code that comes up and says I'm the task tracker or I'm the job tracker. And again, as I refer, data can be accessed, modified, which basically also means that you can accidentally delete it. So even though there is no malicious intent, a user can go in and accidentally cause or format the entire name node, lose all of the data. And an interesting thing is, again, I think Dave Hansen referred to this in his keynote, right? Security is not optional. That's the message that I think security professionals get it, different shades of it, but we all get it, that it is not optional. So why have a system which doesn't have any security by default? And maybe performance, availability, right? Those things were much more important. But I mean, still, why? Right? I'm sorry, this is very hard for me to understand. So a few examples of no security. Just pass the username in the URL for like a job tracker, and it'll know that that's what you are. HTTP authentication allows anonymous access. User impersonation is not too hard. If you have a client machine with access to the cluster, you can become, as long as you have root access on your own client machine, which most people do, you can become any user, and then you can delete everything by default, right? I mean, that's a default security, and maybe that's why no security is called simple security. So it's like a euphemism, right? We have security. It's simple security. So authorization, and again, you will hear this theme like by default a lot. So by default, permissions are not checked. Service level authorization is disabled. ACLs allow permit all access to services. ACLs are at protocol level. There are 10 or so, right, protocols, or maybe less. ACLs allow permit all access to job operations. So basically, if I'm a job and you have multiple jobs running for multiple users, I can go in and start deleting others' jobs and changing the priority of those jobs. However, a positive point is that groups for ACLs can be retrieved from LDAP though. So it supported that. So essentially, you could say that user foo can only do this if he's part of admin group. And I can put that in the standard LDAP and manage it through that. So that was okay, but again, because there was no authentication, I could become that user. So how many of you are familiar with Kerberos? I can't claim to be familiar. So Kerberos saves the day, right? So they added Kerberos support that provides authentication for Hadoop, and awesome, because now you can enforce authorization because you have authentication now. So you can reliably know that if a user says I'm super user, then that user was authenticated using a Kerberos ticket. So that must be the right user. And Kerberos is a very good protocol. So it offers mutual authentication for users and services, right? So things became much more simpler. And as I said, authorization can now be meaningfully enforced. So for encryption, it uses SASL, I think a simple authentication security layer or something. So it's like a framework that you can plug in other authentication mechanisms into it. So it uses Kerberos as the prime one. And QoP is quality of protection. So now you can say, okay, my connection that I use from my client to the name node can be encrypted using quality of protection of confidential, which means encrypted. The data transfer can also be configured for encryption. So now the data transfer, how you access data, how you get the data back, can also be configured for encryption. You can enable SSL for web traffic and web consoles. There's Uzi that also supports SSL with Tomcat config. So things started to get better, right? And you can actually add like hadoop.rpc.protection equals privacy, for example. That's how you can start to configure SASL. And since we have very short time, so I will have some examples. I mean, in case you want to talk about some of the detailed ones, we can talk about it on how to configure that particular instance. And yeah, there's hadoop.ssl.enabled equals true, that enables SSL there. So Hadoop saves the day, or does it, right? Now, trying to find Hadoop admins in a typical IT organization is a challenging task. A lot of times you can get the Active Directory folks to help as Kerberos admins because they use similar technologies. So you can take help from them, but they are not very amenable to helping in the traditional development environment. So IT folks trying to steal IT as an operational resource and bring them to a development thing is very difficult. And as developers, if we try to configure Kerberos, it's very tough. Will enterprises allow Hadoop Kerberos? In most cases, the moment we talk about it, setting up a different Kerberos installation and say, okay, we need 3,000 service principals because we have 3,000 nodes. We need to configure these, add the key tab files, synchronize them across all of these machines. I mean, IT just probably says, oh no, this is we don't want that. We don't want this another separate one to be used. In most cases, they don't even allow one-way trust relationships between the Active Directory and Kerberos KDC. So you run into typical IT challenges. And Kerberos in Hadoop has preconditions. So it says no root access to the cluster or job launcher machines, which is fair because you can access the key tabs and you can access additional things, right? And no communication over untrusted networks. So, which again implies that it's a trusted network. If it's a trusted network, then there are other mechanisms that are possible, right? So, can somebody give me an example of a trusted network? Sorry? VPN? Right. I mean, using VPN to connect. Yeah, correct. So now if I have VPN, I can use other mechanisms. Do I traditionally need SSL in that case, or enabling security between the nodes? So to me, it's like, it's a great thing to have Kerberos. Practically, if you try implementing it, you have to set up a separate DNS server that can basically understand these nodes and physical nodes. Only then Kerberos is really effective. It is cumbersome, and then you have to create the service principals in the right way that Hadoop can start using. So it's not an easy undertaking. So some of the limitations, right? So too many symmetric keys are used in the Hadoop version of Kerberos. You have symmetric keys between the name node and the data nodes. That's how they encrypt their communication. You have symmetric keys between that's used for the delegation tokens between a client and the name node. You have symmetric keys between the tasks and the job tracker. So it's just too many symmetric keys used, and it's very hard to pin down and say, okay, this is the real impact if I compromise this, because it could escalate. I mean, that impact could escalate. In some cases, you could say that, okay, if I get hold of the block access token or the symmetric key that is used to encrypt the communication between the two, maybe I can just compromise the data as it is flowing between the client and the data nodes, right? But then it could escalate. What if data node also stores the symmetric key that it uses to talk to the name node? So now you can intercept that communication as well. So it's very hard. HTTP SpenGo has to be turned on in browsers. And I looked at, I think Internet Explorer had the best support probably. I looked at Chrome and Firefox, and it required settings to make it enable. And that's how you can talk to your web consoles that are using SpenGo security. How many of us have turned on anything in the browser? Okay. Have you really enabled anything in your browser? If I tell you that to talk to my website, you need to enable something in your web browser, would we do it, especially security for professionals? No, because I don't understand it. I don't understand what else I would be exposed to. Where else would that token go? Is that only for intranet zone? Would this SpenGo be only turned on for intranet zone, which means server A and server B, it will start to send my Kerberos ticket? What if I create another one, right? Spoof the domain. Will it send my Kerberos ticket to that server as well? So again, anything that requires us to turn on anything is a turn off, right? It just stops me right there, and I start thinking about alternatives. What else? How else can I talk to those web servers? The Uzi uses a super user which has access to the entire Hadoop stack, and authorization for that is disabled by default. So very, very open. So as noted earlier, to enforce authorization, it must be explicitly enabled. You have to create those users on all the relevant machines where you can start using file permissions to file-like permissions to enforce security. All of these Kerberos credentials have to be mapped to operating system users. And in some cases, it's not too hard. You just take like Kerberos way where there's a principal name / the actual host name, and then add the domain. So you can just strip off and take the first part, principal name, as the user ID and create a user in your operating system. So it's not too hard, but it's something, again, it's like an admin that does it. So ACLs created for each protocol, possibly 10 different protocols. So yeah. Any questions here? So again, this, I'm sorry. Okay, press the wrong key. So no encryption at rest. So it provides encryption over the wire, gives us authentication, but there's no encryption at rest. So I cannot encrypt my HDFS file store using a Kerberos-like mechanism, for example. So again, by default, Kerberos RPC communication is unencrypted. Client to data nodes connections are unencrypted. HTTP communication is unencrypted. So the default thing is what starts getting to us after a while, because you have to force yourself to think of the entire installation and start enabling one setting after another to ensure a fully secure Hadoop cluster. And one more thing, key exchanges happen using RPC, so RPC must be encrypted. So the Kerberos RPC communication, even though it's disabled by default, must be encrypted, because that's how Hadoop sends out the symmetric keys to and changes them every 24 hours, I think, and it allows the data nodes to communicate with the name node using those symmetric keys. So that those key exchanges happen using RPC, and they're all symmetric keys. So that communication must be encrypted. So even if you encrypt everything else and you forgot to do this, it's still vulnerable. So Cassandra, so I won't go too far into it, we can just use the same arguments we had against Hadoop for Cassandra. There's, again, by default, no authentication, authorization, no confidentiality, privacy, or integrity. If you're familiar with Cassandra, it's just multiple nodes. Essentially, they are all equal. There's no master. There's no fixed master. So they all talk to each other. They keep each other in sync. So it's a very fault-tolerant system that guarantees availability at all times. So once you have a server, and if you use Nmap or any one of those port scanners, you can look for some of these servers and ports, and usually 9160 is what it uses. And if there's no authentication authorization by default, you can just connect to it and start listing out information. It's just like SQL injection vulnerability, except that there's no authentication, so you can start listing out everything. So I think this topic has been covered in some talks, including I think one in last year, where I forgot the name of the gentleman that talked about NoSQL vulnerabilities. So this has been dealt with in some detail. I won't go into detailed aspects of this, but basically it's like injection attacks all over again. So CQL is Cassandra query language. You can start, it suffers from, modeled on SQL, so it suffers from the same problems. MDX is multidimensional one, so it used for OLAP, and so you can again start using injections in those. JavaScript injections, where the server side supports JavaScript, you can start injecting JavaScript into that. For example, a star, and comment out the rest of the code. So traditional SQL injection, just in a new avatar for NoSQL. So and again, we know that data duplication, so sensitive data might be in multiple places. To be fault tolerant, it just keeps data in multiple places, spread around geographically. And new attributes again can be added to column families, as we have seen. So for today, let's say if you review the entire schema, so-called schema, and we find that there are no sensitive fields, tomorrow I can just simply add one without anybody's approval. So that's the question we are asking in this presentation. Should we add a V for vulnerability? What do you guys think? Yes? No? Yes? Sort of yes, right? We don't want to commit. I'll say yes. So some of the practical steps, so coming to the last 15 minutes, we'll just talk about some of the practical steps. For example, what we do, what we ended up doing is write our own authentication and authorization plugin. So it has an example of how you can write something simple. So we just created our own, and you just configure it in Cassandra's YAML file, create your own authenticator and your and the authorizer, basically. The good thing with this is you can tie this to your traditional authentication mechanism. You can tie this to your Active Directory, you can tie this to your LDAP, and you can allow users to be authenticated in the traditional way that they expect to be authenticated. Or you can add a token-based OAuth mechanism, and in our case we use an OAuth mechanism. You can add a token-based authentication as well, where it can go and talk to an OAuth server and authorize that particular request without compromising credentials. So that's a good thing as well. So authorization granularity, I think it only supports the key space and the column family one. That doesn't support cell level access. So you cannot say field password or field SSN is only accessible to this user. But it does support at the key space, which is, you can just think about it like a table space one, and column family, which is actually like a table. So it allows, in our case, for example, it allows access up to those levels. So I can say only admin has access to this key space, and these users have access to these column families. So now at least I can separate out those users. And it's not too hard. It's Java, so again, you just have to take examples and write it. It's one of the best ways. Now starting 1.2, the recent versions, they support internal authentication. So this is again something that can be used. where you can create, use Cassandra's facilities to create a user in Cassandra and then authenticate with that user. But yeah, I mean, the only problem is that then it's just internal to that. You can't tie it to your organization one. So I still prefer the authentication and authorization plugin. We must enable node-to-node encryption. So again, it just uses PKI to encrypt the communication between nodes. So you can enable node-to-node encryption between different Cassandra nodes. Client-to-node encryption, again, is SSL. So you can just configure a key store, Java key store on your server side, configure a trust store on the client side, and encrypt that communication. So with some of these things, it makes a Cassandra installation secure in practical terms. It's still not ideal, but it allows us to get rid of the common attacks against Cassandra. For example, you can't connect to it using the Cassandra command line client and get data because it will ask you for authentication. The last one is should. It depends on your threat model. So we should do threat modeling in general, but in this particular case, if it's like within a VNet or VPN type of environment, then you can skip this and just use traditional controls. There are other mechanisms where you can use field level encryptions. I'll talk about some of those as well. But you can enable disk support for encryption. If the cluster is open, then this is something that should be, it becomes a must depending on your threat model. Any questions for Cassandra? So let's talk about some of the enterprise adoption of Hadoop. So enterprise adoption is picking up, and I said that some of the survey I looked at, 52% are using, 50 to 60% are using Hadoop in prod or test environments. These numbers are growing. In a lot of cases, it's just a matter of time for enterprises to adopt a big data installation like Hadoop. So enterprises are adopting this. It is picking up. A few hindrances though. So no encryption for data at rest, right? And we'll talk about the practical mechanisms for this. No security by default and hard to configure, right? And hard to configure the available security. No multi-factor authentication, no strong or adaptive authentication. Kerberos authentication is yet another scheme for enterprises where you have to just put one admin dedicated to this, versus just tying in with the existing mechanism. There is no attribute or policy-based authorization. So for example, you cannot say that user Bob can only access the big data analytics systems from 9 a.m. to 5 p.m. That's his allowed access limit. So you can't do that. You can't even do it based on attributes. So you can't say that SSN is not visible to these folks. Even the last 4 digits are not visible unless you get your manager to stand over his shoulder or something. So that's not there for enterprises. And so differential privacy issues. Are you guys familiar with differential privacy for big data? Anyone? Okay. So basically, differential privacy is a term that refers to combining data sets, let's say. So individual pieces of data do not hold any personally identifiable information, right? PII, let's say. So I have one set of anonymized data, another set of anonymized data. So both are benign, which means I can release this for research purposes, or I can release it for some other need, academic needs, without affecting any security or identifying any individuals. But when these two pieces are combined, that reveals insights and information that allows us to now start identifying people. So the case I read about was, I think issues with this was Netflix, where I think they probably had some issues associated with differential privacy. They released anonymized data with IMDb, one that could be used to identify individuals' taste in movies, and you can start to narrow down their orientation or other details, right? So movie preferences tell a lot about ourselves in some cases. So So differential privacy, again, I think AOL, the other case was AOL, where they released anonymized data which was used with just standard phone book data to identify users. So again, it was a big issue. I think some key folks there lost their jobs because it was that serious. So differential privacy is what scares, I mean the litigation and the liabilities is what scares enterprises, where they say, oh wait a minute, let us first analyze this. If you're not clear, we will not implement this particular one. So if you don't have controls around those, we will not implement. Audit and compliance. So if you are a typical enterprise, you are subject to some kind of audit. If you're a public company, to SOX. If you're a data center type of service, to SSA 16. There are different compliance, or HIPAA or PCI or one of those things. Those compliance standards, do not approve of the big data installations, because again, there are a lot of things that we don't know. There are a lot of things we can't secure. General question is key management. Who has access to these keys? Very hard to answer that for a big data installation. Same thing for audit. Very hard to pass audit. So enterprise adoption suffers from, this suffers the overall adoption. Vulnerability and patch management is again one area where typical IT basically looks for answers. Say, okay, you have these clusters, what if there's a security issue in Hadoop? How will you go and patch that? And if you have like a 4,000 node cluster, it's very hard to go and manage these. So Project Rhino is something that will accelerate Hadoop adoption by supporting some of these things. I'm waiting for this because I think it has a lot of promise. It allows a token-based authentication, which is what I think most of us are moving towards. That frees us from traditional user password mechanisms after a while, and you just send the token. Limited capabilities expires quickly. You can send these tokens out, and Project Rhino promises to support some of those. Encryption will be there on both, I think, at rest and in transit. There's also support for cell level authorization in HBase. So for example, you can say that SSN field is protected for these users. So this will be a significant step forward. But since that's some time away, what are the other practical steps that we can do for Hadoop? We need to perform threat modeling, and this is really key, because if you walk through the entire documentation of Hadoop, it will take days to fully implement all of those mechanisms, and that, even then, there's no guaranteed security because you might have missed something, right? So threat modeling will allow you to pin down what really should I be securing based on my organization, based on my compliance, audit, IT needs, based on my policies or my users. What exactly should I really be doing? What are my threats? What is my input? What's my output? What's my box in here? And that will give you the key areas or threat scores that will say, okay, these are the ones with elevated threat or risks that you can start to look at. So again, this is something that organizations typically do, is just eliminate sensitive data from Hadoop. If it's not really crucial to your big data installation, filter it at the source. So for example, SSNs, put some mechanisms to go and filter this data out. Analyze what data you're getting it from your sensors, or video feed, or whichever mechanism you use big data for, and filter some of that sensitive data out. Phone numbers, for example. For the ones that you cannot eliminate, use field level encryption, and use OS and file level encryption mechanisms. I think you pointed that out. So that's a good one. But avoid vendor lock-in, in my opinion. For example, Cloudera distribution has or simplifies some of these things. So does Hortonworks distribution. Intel also has a separate distribution that targets encryption, but again, it requires, I think, some capability in terms of Intel processors. So there are a lot of catch-to-do situations with some of these. So in general, I avoid a specific flavor just because my users would be used to that and very hard to wean them away. But it could be a viable one where your threats are too high to simply do it on yourself. You can use a commercial flavor of Hadoop, for example, or Cassandra. For now, run in a secure environment. I mean, really, so I looked at all of these aspects, and for a typical enterprise, if you want to secure it, it is very hard to do it in a time frame and be able to support it, for an organization. So the best answer is to run in a secure environment. If you're in a cloud one, use a private cloud type setting, VNet in Azure, for example, or AWS. Create your own virtual private network there. Segregate that network, create public and private subnets, ensure that your data or data nodes are only running in your private subnets, your access servers are running in your public subnets. Create a gateway that controls access to these servers, so you maybe have to log into that gateway and then you get access to that cluster, and you can provide access control at that layer as well. And defense in depth, so exactly like that only allow traffic to flow from the trusted nodes to the innermost nodes. So that way you get one more additional layer where you know that if somebody compromises a data node, you will not be able to come the other way around. The last one is what we did as well, in addition to some of these. So most of these we have actually implemented. There are some that are still work in progress or there's a decision pending on some of those. So like we developed our own custom interface to accept jobs. This freed us from having to expose the entire Hadoop job config API that allows user A access to user B. So we wrote our own. There's a thing, there's a open source project called Apache Knox that can enforce a single point of access for authentication and access control. We are in the process of trying this out. What I do not know is how it affects scalability. So there's an open question with this, and that has to be seen. It's too early to actually figure out. And if you can't wait for the project Rhino to complete, and depending on the threat model, you'll have to enable Kerberos, right, and authorization. So it just boils down to setting a bunch of parameters to true. Not terribly hard, but then I think you still need a Kerberos admin for some of the initial DNS server settings. Integrate logging. There are a few examples there. Encrypt the Kerberos RPC. Remember the key exchanges part, so this must be encrypted if you are using Kerberos. Encrypt the other communications as needed, but in general the RPC communication, the key exchange mechanisms must be encrypted. So those are the general. I don't think I had. Yeah. So use LDAP to manage groups. Develop and deploy custom authentication filters for web consoles. So for the web consoles, what you can do is we wrote our own filter, servlet filter, and just plugged it in there, and that allows us to do our own authentication instead of relying on Spengo, which I'm totally against. So this allowed us to use our own authentication mechanisms, our own single sign-on or authentication mechanisms. LDAP to manage groups is again something that should be done, because you don't want to create file level groups on all of this and have to go and manage these groups.